And 12.2 is just one day for the lesson. It's on being able to draw and find angles that are in standard position, so understanding what that means and being able to draw those or identify what an angle would be, along with identifying what are called coterminal angles. And then the second part of it is being able to convert between degree measures and radian measures for angles. So I mentioned angles are measured not only in degrees but in radians as well. So looking at how to convert between the 2 degree measures and then using radian measures to find the arc length of a circle and applying that in different contexts. So the first part of this is talking about what the standard position for an angle is and drawing an angle in standard position. So an angle on a coordinate plane, so you would have what looks like, well, what is an x and a y axis, and then you see some degree measures are labeled on here. But an angle on a coordinate plane is in standard position if the vertex of the angle, so that corner part of the angle, is at the origin, and one ray is on the positive x-axis. And the ray that is on the x-axis is called the initial side of the angle. So this here, for the angle that's drawn, would be the initial side, that ray. And the ray that rotates about the center is called the terminal side. So this would be the terminal side here. And then it gives some more information in this box because you do have angles that have a positive degree measure as well as a negative degree measure. So if the measure of an angle is positive, the terminal side is rotated counterclockwise. So you would start on that positive x-axis and rotate around counterclockwise, whatever your degree measure is. There is, or one full rotation, you may remember from geometry, is 360 degrees. So they do have labeled up here, you're starting at 0 degrees. If you go a quarter of the way, a quarter of 360 is 90, half of the way is 180, 3/4 of the way is 270. A full rotation would be 360 degrees. So really an angle of 0 degrees and an angle of 360 degrees, we're going to see those are coterminal because if you draw them out, they're actually drawn as the same angle. Their terminal sides are the same. So counterclockwise, if the degree measure is positive, if the measure is negative, then you still start on that positive x-axis, but you end up going clockwise around, so you start out going down and around versus up and around. And then kind of use these quarter reference points, the 0, 90, 180, 270, to figure out the placement of where your angle or your terminal side should be. And then one other thing before we go through some examples here, the terminal side of an angle can make more than one complete rotation. So if you, for example, have an angle that's greater than 360 degrees, so for example, if you make a complete rotation of 360 and then you make an additional rotation of 120, you'll get an angle that measures 480 degrees, 360 plus 120. So if your angle is greater than 360, you should be going more than one complete rotation around. And then notice how you draw that. You do draw, you're kind of creating what would end up looking like a spiral as you draw that around to show the direction your angle is headed. All right, so we're going to look at examples 1, 2, and 3, drawing those angle measures in standard position. So example 1 is drawing an angle of measure 210 degrees. So again, if I'm starting at, or my initial position is at 0, if I go a quarter of the way, that's 90. If I go half of the way, that's 180. 3/4 of the way is 270. So 210 would be 30 degrees more than 180. I would have to go 180 degrees plus an additional 30 degrees and from 180 to 270, that's 90. So you're kind of just approximating where that would be. It's a little less than halfway between 180 and 270. I'm not going to get that picky unless it's clearly, like if your angle measure was drawn closer to 270, that's obviously not 210. So that would be where the terminal side is. So you draw in where the terminal side would be, but then I do want to show the rotation that that terminal side made. So I started at 0, going counterclockwise, and I ended at where that terminal side is. So I'm showing that direction that it's headed as well. And as it shows here, if it does go around more than one time, you need to show that. So that's 210 degrees positive. Example 2 is a negative 45 degrees. So if it's negative, I'm starting out going clockwise. So I'm still starting at an initial position of 0. But now if I'm starting out going down, that makes a quarter of the way. This, rather than labeling it 270, I could label this as being negative 90. So a quarter of the way would still be 90, but it would be negative if I'm starting out going clockwise. So then, since 45 is halfway between 0 and 90, I know that terminal side would be halfway in between the 0 and negative 90 mark, and I would just show the rotation that terminal side made, starting at 0 and going to where I drew in my terminal side. Okay, so not too bad. It's just more of you figuring out, breaking up that 360 degrees where your terminal side should end up. Example 3 is an angle of 600. So since this is greater than 360, we're going to be making more than one rotation. It is positive. So I need to figure out how many rotations this is. So what I can do is, I know if I go around once, that's 360 degrees. So I'm going to take 600 and subtract 360. And so that means I have to go around one time, plus I have to go an additional 240 degrees. So I'm still going to label here so I know approximately where that is, my 0, 90, 180, 270. So 240 would be, again, between the 180 and the 270. And it'd be a little closer to the 270, so 60 degrees past the 180. So about right here is where my terminal side is going to end up. But the way I'm drawing in my rotation direction here is I'm starting at 0. I have to go all the way around once, plus then I'm going all the way around to that 240 mark. And that shows an angle of 600. Okay, so any questions right now about drawing an angle in standard position, positive or negative? Okay, and then actually what we had to do to draw in the 600 degree angle leads us into what are called coterminal angles. So 2 or more angles that are both in standard position that have the same terminal side are called coterminal angles. So as I mentioned, 0 degrees and 360 degrees have the same terminal side. They would look the same if you drew them out. So those would be coterminal. 600 degrees and 240 degrees would have the same terminal side. They're coterminal. So the way that you can, well, this explains here how you can find coterminal angles. This just gives an additional example. 60, 420, and negative 300 degrees would all be coterminal. You could even say 270 degrees and then negative 90 degrees. Those have the same terminal side based on how I labeled these. So how you determine coterminal angles, they're found by adding or subtracting a complete rotation, so 360 degrees. So if I am given the angle 60 degrees and I want to find a positive coterminal angle, I would add 360, so 420 would be a coterminal angle. I could keep adding 360 to find more. If I want to find a negative coterminal angle, I would subtract 360, and that's where the negative 300 is coming from, and I could keep subtracting 360 to get more negative coterminal angles. So you might see problems like this, where it says find an angle with a positive measure and an angle with a negative measure that are coterminal with the angle that's given. So if I have an angle of 210, I could add 360 degrees to get a positive coterminal angle. So 210 plus 360 is 570. So that would be a coterminal angle with a positive measure. However, you wouldn't have to have 570 as your answer. I could add 360 again, and you could give the answer of 930 degrees. That would also work. So there's multiple answers for these types of questions. And then if I want to find a degree with a negative measure that's coterminal, I would take 210 and subtract 360. So negative 150 would be a negative coterminal angle. I could subtract 360 again, so I also could have given the answer of negative 510. So again, multiple answers. What I would like you to do is number 5, and I may not walk around for this because it should be pretty quick, but I want you to find a degree measure that's positive and negative that's coterminal to negative 480. Yeah, make sure one of your angles that you're giving is positive, one of them is negative. I might just make a quick walk around and make sure you got a chance to do it, and then I'll show what I have and compare it to what you have. But just make sure one's positive, one's negative. Okay. And if you have something different and you want to check if it's right, let me know. So I would have given, or rather I noticed, you probably noticed if you add 360, it's still negative. So negative 120 would be a negative coterminal angle. If you subtracted 360 and you gave 840, that'd be fine. So then I would have to add 360 to the negative 120 in order to get a positive coterminal angle of 240. Anybody give anything different? Okay, just make sure when you see that type of problem, as simple as that might seem, I often see students just go through the motions of adding and subtracting 360, and if both of your answers end up positive or both end up negative and you don't realize that it's asking for a positive and a negative, just make sure you're fully reading directions and you're giving the answer in the correct form. Okay? Any questions before we move on with coterminal? Okay, and this is all building. So as we move forward, we'll be building into trig functions with specific degree and radian measures that will involve finding coterminal angles later on. So it's all building into other, it's all kind of separate pieces now. It'll come together. The next part then is converting between degree and radian measures. So the beginning here defines what a radian is. So I know we usually work in degrees, but understanding what a radian is it could be helpful to know why, or to understand when you're working through it. So it says angles can also be measured in units that are based on arc length. So radians tie into the length of an arc of an angle or around a circle. So 1 radian, this is the definition, kind of wordy. So 1 radian is the measure of an angle theta in standard position with a terminal side that intercepts an arc with the same length as the radius of the circle. Okay, very wordy. So radian kind of sounds like radius. They're very close to the same word. 1 radian is the measure of an angle theta. So that in this diagram, this angle theta would equal 1 radian. And it's the measure of the angle theta in standard position when the terminal side intercepts an arc that has the same length as the radius. So notice in this diagram, the radius length is r, the arc length is r. So that angle then, when the radius intercepts the arc so that the arc length is the same length as the radius, that angle is called a radian. So that's how it's defined. Then it goes on to say, since the circumference of a circle, since radians tie into the arc length, the total distance around a circle is circumference. The circumference of a circle is 2 pi times the radius, so 2 pi r. Therefore, if r is representing a radian essentially, 1 complete revolution around a circle will equal 2 pi radians. Okay, so 1 complete revolution in degrees is 360. 1 complete revolution in radian measure is 2 pi. So radians are often, when you see angles given in terms of pi, it's usually a radian. And then, so it goes on to say, since 2 pi radians equals 360 degrees, this gives us a conversion factor to convert between radians and degrees. So then you can relate radians and degrees saying 2 pi radians equals 360 degrees, or if you divide these both by 2, pi radians or 1 pi radians would equal 180 degrees, half of 360. So halfway around a circle, 180 degrees is equal to pi radians. So then this gives that conversion unit. So if you're starting with degrees and you want to convert to radians, you will multiply by the number of, or you'll multiply that number of degrees given by, you want the 180 degrees on the bottom so that the degrees cancel out, and you want the radians on top so that your answer's in radians, so you're multiplying by pi over 180, and then that is just flipped. If you're starting with radians, you want the radian measure to cancel out, so pi radians is on the bottom, 180 degrees is on the top, but it's coming from that conversion unit here. So we're going to look at 2 examples, just converting from degrees to radians and then radians to degrees, because we'll be working in both in this chapter, and as we're going to see in the next set of examples, when you're trying to find arc length, your angle has to be in radians, so there is a place where you have to be in a certain measure. So if we have 120 degrees, and I want to change that into radians, I would, just so you don't have to look at this chart every time, as long as you remember pi radians and 180 degrees are equal to each other, I want to multiply this by, and if it helps you can put it over 1. Since I want degrees to cancel out, I want degrees on the bottom, so I'm going to have 180 degrees on the bottom and then pi radians on the top. You do not have to write the word radians though. So normally when you see an angle measure like in number 7, this doesn't say radians after, but I know it's in radians because there isn't a degree symbol. So if there is a degree symbol, it's in degrees. If there's no degree symbol, then the angle is in radians. That's how you know. It may not say radians after it. So if it's in degrees, it has to have a degree symbol, meaning you should also be writing the degree symbol if you're working in degrees. And then to multiply these, you would just multiply across the top and the bottom and simplify, or you can cross simplify. So I could cross simplify 120 and 180. I can divide them both by 60, so the 120 would become a 2, and the degrees do cancel out. Those units of degrees would cancel each other out, and the 180 divided by 60 is 3, and then if I multiply across, I have 2 pi over 3. So 120 degrees is equal to 2 pi over 3 radians. You can write radians after, you just don't have to. Make sure you're not putting a degree symbol though. Okay, so then 7 is just the reverse. Oh, Adler, question? Yes, if you also wrote 2/3 pi, yes, that is correct as well. Make sure the pi, though, doesn't look like it's in the denominator with the 3. That would be the only thing that would not be correct. For this one then, for radians, so we know this is in radians, there's no degree symbol, so I want to convert it into degrees. So I'm using the reciprocal of that conversion factor. I want 180 degrees on the top so that the radians cancel out on the bottom. So I'm multiplying by 180 degrees over pi radians. So here the unit pi will cancel out. It's not a unit, but the pi's will cancel. I have 3 then times 180 over 8. I could simplify the 8 and the 180. I can't divide 180 by 8, but I could divide them both by 4. So the 8 would become a 2. The 180 degrees would become 45 degrees. I still then have to multiply the 45 by 3. So I would get 135 degrees divided by, I still have 2 on the bottom. And then even though I can't divide this evenly, I would divide that by 2. So I would have 67.5 degrees. And you should have degrees as the unit. Oh, negative. Yes, thank you. Thank you for catching that. Okay, any questions on those conversions? All right, and then we'll actually be using radians, so it doesn't seem like we're just converting for no reason at the moment. And this is something you've also done in geometry. So a central angle, just some definitions first of all. Central angle of a circle is an angle with a vertex at the center of the circle. And if you know the measure of the central angle and the radius of the circle, you can find the length of the intercepted arc. So here's the definition for how to find that and the formula for how to find that. So for a circle with radius r and central angle theta in radians. So the central angle theta, if it is given in degrees, has to be converted into radians before you substitute it into that formula. If it's in degrees, your answer will not be correct. So the central angle has to be in radians. The arc length s equals the product of r and theta. So the arc length s is the radius times theta when theta is in radians. So I have 2 examples here that are set up a little bit differently. 9 is more of one you have to interpret. So example 8, you're given a circle with a diameter of 9 centimeters. Find the arc length if the central angle is 60 degrees. So we need for arc length, we need the radius, and we need the central angle in radians. So starting out, if the diameter is 9, what is the radius? 4.5. And then our central angle right now is 60 degrees. I have to convert that into radians. So the central angle theta is going to equal 60 degrees. I'll put that over 1, multiplied by the conversion factor to change degrees into radians. So that would be pi over 180 degrees, like we did in example 6. And I can cross simplify. I can divide 60 and 180 by 60, and the degrees cancel out. So the 60 becomes 1. 180 divided by 60 is 3. So 60 degrees is equal to pi thirds, or 1/3 pi, if you wrote it that way. And then once you have the radius and the central angle in radians, you just substitute it into this formula. So the arc length s is equal to 4.5 multiplied by pi over 3. And what I'm actually going to do here, because I could write this as 4.5 pi over 3, but having a decimal in a fraction isn't simplified. So 4.5 is really how we got 4.5. We did 9 divided by 2. So I could, instead of writing 4.5, write 9 over 2 times pi over 3 to multiply fractions. I can then cross simplify the 9 and the 3. So the 3 would become a 1. 9 divided by 3 is 3. And that gives me an arc length of 3 pi over 2, or 3/2 pi. And what would the units be for that arc length? Centimeters, yep. The same units as the radius. So this would be 3 pi over 2 centimeters. It doesn't specify, so you could also give, like you could type that in your calculator and give an approximation to that as well. This would be the exact answer, though, in terms of pi. Did you have a question, Curtis? Yes. So coming from the formula, for whatever reason, the formula is S equals, S is the arc length. I'm not sure where the S came from, but yes, in the formula it's always S. Okay, any questions on that? 9 is one you have to interpret a little more. So this one says the steering wheel on a monster truck has a radius of 11 inches. And we know steering wheels are circular. How far does a point on the steering wheel travel if the wheel makes 4/5 of a rotation? So if we had, say this is your steering wheel, here's the center approximately. So we know the radius is 11 inches. So say that point was starting here, and we're saying if it goes 4/5 of the way around, so say it ends up here, that's where that ends up. We want to know how far it traveled, so we're looking for this distance along the circle, which would be the length of that arc. And we have the radius, but we would need to know what that central angle theta is. Okay, any ideas on how you'd find theta? That does work, but that's still in degrees. So you'd still have to convert it. Yep. Rather than doing or multiplying 4/5 or finding 4/5 of 360 and having to convert it to radians, what you could do is 360 degrees is 2 pi radians. So rather than taking 4/5 of 360, you could just take 4/5 of 2 pi, and then you're already in radians. So theta would be 4/5 of 2 pi, which this 2 pi is like 2 pi over 1, so that would be 8 pi fifths. That would be the radian measure of the central angle. We have the radius is 11, so then to find the length that point traveled, which is the arc length S, that would be 11 times 8 pi over 5, and the 11 is over 1. So the exact answer would be 88 pi fifths, or 88 over 5 times pi. And that would be measured in inches. Okay, any questions on that one?